Hey guys, today we're going to be looking at how to calculate molarity and some dilutions. First up is molarity. Molarity is the concentration of a solute in a solvent. Remember, solute is the thing that gets dissolved in the solvent. And the equation for that is going to be a ratio of moles of solute to liters of solvent. And what that looks like is molarity equals moles over liters, and molarity is going to be a capital M. So if you wanted to write that in equation form, as it is there, you'd say M equals moles divided by liters. All right, so let's look at an example problem for calculating molarity. Our example says a 85 milliliter aqueous solution contains 7.54 grams of iron 2 chloride, which is FeCl2. Calculate the molarity of the solution. All right, so we're going to do this problem using the guess method, just like we've been working problems in the past. So for this guess method question, we are looking at molarity. So we need to see what our given information is. If you read through the question, the first thing, or the first number you see is 85 milliliters. So we're going to write that down as a given. That's 85 milliliters. And we also have grams over here. Let me choose a different color highlighter. There we go. We got 7.54 grams. All right, so let's look at these and see what variables they should be. Milliliters is not quite what we want. It is a volume, but our volume needs to be in liters. We've got to have liters. And you can get to liters by dividing by 1,000. 1 liter equals 1,000 milliliters, or 1 milliliter equals 1 over 1,000 liters. So we have to do 85 divided by 1,000 to get our liters. So to divide by 1,000, you just have to move the decimal place 3 times. So we're going to do 1, 2, 3. And fill in our decimal with the 0. So you get 0.085. And that's not going to be milliliters anymore. It's going to be liters. And then the other thing is that we have grams, and our equation calls for moles. So we're going to have to do some mole to gram conversions. Now I'm going to make this smaller and do my moles to grams conversion over here. You might have to do yours on a separate sheet of paper or find some space down at the bottom. But you've got a chart here that will change our grams into moles. We're starting with 7.54 grams, and that is grams of iron 2 chloride, or FeCl2. Now to go grams to moles, we have to know the molar mass. 1 mole equals molar mass. So we need the molar mass of iron chloride. To find molar mass, you do iron and chlorine. We've got 1 iron, 2 chlorines. And you got to whip out a periodic table for this. Here's my periodic table. And for some reason, every time I do this, I end up with 2. I need to fix that somehow. So here's my periodic table. Looking at iron first. Iron is 55.845. Hold on a second. Oh, yep. Turns out I can use a lightsaber to point to my answers. Yep, that's pretty cool. All right, so iron is 55.845 right there. So write that down. 55.845. And chlorine here is 35.453. Write that down. What did I say? 35.453. Right there. All right, now you got to do some quick maths to get your total molar mass. You multiply these numbers, get 55.845 grams, and let's see, that's 70.906 grams. Add those two things up, and you get 126.851 grams for iron 2 chloride. All right, so that goes over here with molar mass. 1 mole equals 126.851 grams. All right, now I got to decide which part goes on the bottom, grams or moles. We got grams on top first, so grams has to go on the bottom next. We'll put 126.851 grams of iron chloride on the bottom, which is the same as 1 mole of iron chloride. Then you got to get your actual answer from this. Multiply your two numbers on top, divide by your number on the bottom. I cannot do that math in my head, so I'm going to pull out a calculator real quick. Do 7.54 times 1 divided by 126.851 equals 0.0594 moles of iron 2 chloride, which I'm then going to use in my givens. All right, got to bring the problem back up. And we said that 7.54 grams is equal to 0.0594 moles. All right, so now we've got liters and moles, which are the two things that our question asked for. And we are calculating the molarity. Calculate the molarity. All right, so that's going to be a capital M. Now our equation, which we said up here, is that molarity equals moles divided by liters. Great. And this is very nice because it's already solved for the variable we need. We don't even have to do any algebra. All we have to do is substitute. We leave M alone because it's what we're looking for. For moles, we put in 0.0594 moles, because that was this number over here. And then for liters, we put in 0.085. Then all you got to do is type that into a calculator and divide. 0.0594 divided by 0.085 equals 0.699. And the unit for that is molar, capital M, which is moles per liter. All right, and that's about all there is to molarity. You might have to solve for liters or for moles. I'm using a little bit of algebra. If you don't know how to do that, please contact a teacher and find out. All right, next up we have dilutions. All right, dilutions are what happens when you add in more of a solvent, okay? So it'd be like taking some coffee, which is stuff dissolved in water, and you pour a bunch of water in it. You got watered down coffee. That's a dilution. You decrease the concentration by adding more of the solvent. The equation for dilutions is M1 times V1 equals M2 times V2. M is molarity, which is moles per liter, and then V is volume. Now what's crazy here is that you can use any unit you want to for volume. You just got to have the same unit on both sides. So you could use milliliters and milliliters, you could use liters and liters, you could use gallons and gallons. You could use literally whatever unit you want, but it's got to be the same unit for both volumes. And as it did in gas laws, 1 represents before a change and 2 represents after a change. All right, so let's look at an example using the guess method once again. Our example says, how many milliliters of a 0.75 molar solution are needed to make 50.00 milliliters of a 0.15 molar solution? And that capital M there is for molar. It stands for moles per liter. All right, so we're going to go look for our given information to write under the G for the guess method. First up, we've got a 0.75 molar solution. That is going to be molarity. So we'll write 0.75 M equals, and this is going to be M1, okay? And then we are going to make 50 milliliters, which is a volume of a 0.15 molar solution. So we'll do 50 milliliters equals volume. That's the volume we're making, so it's volume 2. And then we've got 0.15 molar. It's going to be our molarity 2. All right, and we're looking for how many milliliters we need, so that's going to be volume 1. The equation is the dilution equation, M1V1 equals M2V2. And we need to solve that for V1. To solve for V1, we'll divide by M1 on each side, canceling out M1 over there to get V1 equals M2V2 over M1. And then we substitute into that. V1 equals M2. M2 was 0.15 times V2, which was 50. Remember, these can be in milliliters. And that's divided by M1, which is 0.75. Then you type that into a calculator, which is going to get you a volume 1 of exactly 10 milliliters. And there you have it. That's how you do dilutions. So you could solve for any variable in that equation, M1, V1, or M2, or V2, just depending on what the question asks for, using a wee little bit of algebra. As always, if you got questions, please let us know by email or by comments.